Hi everyone, this is Amy from the Helms Academy, and today we're doing a math roundtable recap for our geometry lesson on September 10th, 2020. So first we went over the steps to solving a word problem as we always do, and our steps are to highlight or underline the important information, to determine which operations are needed, and then to write out the problem using the numbers and operations. And from there, we can solve. So this particular math roundtable is special because we're talking about geometry. When we talk about geometry, it's really important to know your math formula sheet. So the sheet that you see on the screen here is for the HiSET exam. And there's also a separate one for the GED exam and a separate one for the TASC exam. You can find them by searching the name of your test and then typing in formula sheet, and they should pop right up on a Google search. So today, when we're talking about word problem 1, it says, Charlie wants to know the area of his property, which measures 120 feet by 150 feet. Which formula will he use? So what's interesting to me about this problem is they're not asking me to solve, they're asking me which formula will I use. So that's why it's also important to look at both what they're asking and also what the options are in the A, B, C, and D here, multiple choice, because that will help us to narrow down what we're going for. So here, I know he wants to know the area, and I see what the area is. It says 120 by 150. When I see area written that way, it's going to cue in my head that that has to be a rectangle. So I'm just going to draw a little rectangle so that I know what I'm looking at. So I see 120 by 150, and I see the sides there, and that would help me understand what I'm working with. Now, to figure out what formula I'll need, I need to remember what is the formula to use if we're trying to find the area of a rectangle. Well, I know the area for a rectangle is always going to equal the length times the width. So I'm going to look at my options. I see A equals L times W, and that's the correct answer. For word problem 2, it says, Aaron is painting a bedroom with 4 walls, each measuring 8 feet by 5.5 feet. Ignoring the doors or windows, what is the area to be painted? So again, I see that we're painting something and we're getting the area of that. So area is a keyword, and then my measurements are keywords. And the other big thing here is I need to pay attention to any numbers that are written in their word form. So do you see in that first line where it says 4 walls? That's going to be important information too. So again, I'm going to draw it out. I'm going to imagine the wall 8 feet by 5.5 feet, and that way I can figure out what the area of that wall is. Now, it's not just that though. I also need to do that times 4 because we have 4 total walls that are that same area. So here, we're going to do 8 times 5.5 because that will get the area of 1 wall. But then we need to multiply again times 4. And when we put all of that together, we get 176 feet squared. Area will always be measured in feet squared, or whatever the unit is squared, with the 2 above it as an exponent. So remember, if you're writing the answer for area, to include that piece. For word problem 3, it says, what is the volume of a ball whose radius is 4 inches? Round to the nearest inch. And it tells us that pi equals 3.14. That's a clue to me, because if I see pi equals 3.14, then I bet I'm going to be using a formula. So I'm going to go to my formula sheet and see what it says. Here's the section of the HiSET formula sheet that has to do with volume. And you can see it shows volume for a prism or a cylinder, a pyramid or a cone, or a sphere. So I need to figure out here what I need. It says a volume of a ball. Well, a ball, in geometry terms, is going to be a sphere. So I'm going to use the formula that you see there. Volume equals 4/3 times pi times radius cubed. So when I rewrite that, I'm going to keep the 4/3. I'm going to replace pi with 3.14 as it told me to do. And then I need to fill in what my radius is, which is 4. And we need to keep the cubed there as well. Now, using the order of operations, I am going to do my exponents first. Everything in parentheses is just a single number, so I can skip right to the exponent step. So 4 cubed, or 4 times 4 times 4, is 64. And you can see I replaced that on the third line there. So now I just need to multiply across. And when I multiply across, I see that the volume is 267.946667. Well, that's not my final answer because I need to round to the nearest inch. So because it has a 9 after that decimal place, the decimal point, then I'm going to round up to 268. And the way I rate this is in inches cubed. So you'll see that inches to the third, and our final answer is B. Word problem 4 says, how many degrees does a minute hand move in 20 minutes? So when I think about this, I'm thinking degrees. Are we talking about temperature here? Well, no, this isn't about temperature. It talks about a minute hand in 20 minutes. So I'm getting the image of a clock, and I'm guessing if we're talking about degrees, it has to do with angles on a clock. So this is wondering, in 20 minutes, how many degrees does this move? Well, I'm going to pull up some visuals. These visuals would not be included on the test, but they will be helpful for us today. So we can see the degrees on the right side of a circle. And you can think about this logically, right? Think of a 90-degree angle is always that right angle there. You can think about if you turn from one direction to another, you might do a 180-degree turn, or if you do a full circle around, that's a 360. So some of these things you probably heard before or worked with before. So we can keep that in mind when we're solving this problem. So think about 20 minutes on a clock and what degree that would be when we look at the degrees here. Now again, you won't have these visual aids. So while you can maybe sketch these out and take a good guess, the best way to solve would actually be to make a proportion. So think about it this way. How many total degrees do we have in a circle? 360. And how many minutes do we have on a clock? Total minutes? 60. So if we want to figure out what 20 out of 60 minutes is in terms of degrees, I can set it up like a proportion. 20 minutes out of 60 minutes on a clock is equal to how many degrees out of 360 degrees on a full circle. So to solve that, we're going to cross multiply our 20 times 360, and then we're going to divide by our other number, which is 60. So in our cross multiply, we get 7,200, and we divide that by 60 to get our answer of 120. So the final answer there is 120 degrees. Now, I want to go back just to look at our clock and our degrees. You can think about it simply as just thinking, okay, 15 minutes, right? We know 15 minutes would be going from the 12 to the 3. That would be a right angle. So we know that's 90 degrees there. So 20 minutes is going to be more than that. So right away, I can root out A and C, 20 degrees and 60 degrees, because they don't even meet the minimum of 90 degrees, which I could guess pretty quickly. So we could get it down to 2 answers very quickly. And if you were in a rush and trying to finish up some answers for a test because you were running out of time, then I would suggest using that technique as a way to at least limit yourself down to a few options and take the best guess from there. Thank you so much for solving with me today and checking out these problems. I hope you learned something new and that you'll subscribe to our YouTube channel. You can also check us out on Instagram, Facebook, and at helmsacademy.org.